they use VESDA in their data centers, I use VESDA, and they just go tick compliant, so it's very good. So, Tom Stilwell.
Thank you. Just finished my presentation. Can you hear me okay? Right. I'm Tom Stilwell, and I am with a company called Xtralis, a company that manufactures the products known as VESDA. And I wanted to ask a quick question to people, and you might have heard my feelings one way or the other, how you answer it. Who had heard of that term VESDA before you came into this conference this morning? Okay, a few minutes. Anybody want to take a shot at what that's an acronym? Take a shot at what that stands for?
Very early smoke detection alert.
4 out of 5. That's very early smoke detection apparatus. VESDA. Okay. Very early smoke detection apparatus. It's a product that's been around in basically 2 different forms since about the early 1980s. And in its current form, or its second generation, that's what we'll be talking about here today. First, just a couple of words about Xtralis, who we are as a company. We're a worldwide supplier of very early warning fire detection equipment, known as VESDA. We're based in Melbourne, Australia. Our North American operations are headquartered in the Boston area, a town called Stilwell, Massachusetts. If you haven't been there, doesn't matter. Okay. We manufacture VESDA on the fire equipment side, but we also have a security end of our business where we manufacture remote video monitoring equipment. We used to be a company called Vision Systems. We did change our name in June, and that really got kicked off about 2 years ago when we were acquired by private equity partners. Couldn't keep the Vision name in the process, so we had to change. Other than that, we're still the same company, same people. I personally have been with the company for about 3 years now, and extensive fire alarm system experience prior to that. And I'm based in Cleveland, Ohio. And for that reason, after about 8:30 tonight, we'll be nowhere to be seen, okay, except in front of the television. So, and I fight with my headquarters all the time because they happen to be from Boston. Okay, on with the presentation. I'm working with a PowerPoint presentation, but this is not a scripted kind of a thing. So my point is, if you have a question, either blurt it out or raise your hand, and let's get it on the table. You won't throw me out of sync here. I want to talk today about what air sampling smoke detection is, ASD on the moment. Generically, that's what VESDA is, okay? Air sampling smoke detection. That's the term you'll see used in National Fire Protection Association codes. You'll also see aspirated smoke detection used. Why do we need something other than probably the more familiar thing everybody has seen, which is what we call spot detectors up on the ceiling? So why do we need this thing? What does it bring to the table? A brief look at our overall product range. It's not just one entity that we make. We have a wide range of products for different types and sizes of applications. And then a quick review of standards that are covered, that deal with the types of applications we're all involved with here. Okay, so kicking off. What is air sampling smoke detection? I like to say it's pipe. It's pipe installed in the protected area. And in that pipe, as we show in the illustration here, we have holes that are either drops, we would call them, attached to the pipe. A drop that can be, the pipe can be up in the ceiling and a drop down with a hole located in the bottom, much like the sprinkler system in this building is designed. Or it can just be holes drilled directly in the pipe itself. Either way, it works fine. We conceal the pipe if we want it to look pretty, or we put the holes in the pipe if it doesn't matter. It actually gives you a slightly lower cost installation if you pipe we normally use is 3/4 inch diameter chlorinated polyvinyl chloride. It's CPVC for short. The reason we use this pipe is because we had gone out and gotten it listed and approved specifically for air sampling and smoke detection. It's listed and approved for use in air plenum spaces because we do have to put it in return air plenums or supply air plenums from time to time. So it's got the right fire retardants and smoke generation characteristics for that as well. So we put pipe in a protected space. And then we have a detector, the VESDA detector, connected at one end of that pipe. And it's actively drawing air samples in through the holes in the pipe by means of an aspirating fan that's located in that detector. After we pass through the fan, what we do is we come into a detection chamber by way of a filter. The filter is there primarily to get the rocks out so that we can see the pebbles. That's how we compare dust, if you will, that's in the air compared to smoke particles. We want to see smoke, and that's all we want to see. So we pass through a filter into the detection chamber, and in that chamber we look for smoke. And the way we do that is pretty simple. We say this is a laser-based detector. I have one right here, by the way. This happens to be our smallest unit. Here's one of these entities that's got a pipe entry point on the top here. The way we detect smoke in the chamber is pretty simple. We take a laser similar to the one I'm holding in my hand right here, and we shine it through a chamber. And if I'm a smoke sensor, we actually have sensors installed that are located around this light source. Ordinarily, I cannot see that laser beam shining across, but if something gets in its path, I can see it. Smoke particles, for instance. Smoke particles in very, very small quantities of different sizes. We can see those things by means of a laser passing through the chamber. And that's transmitted into a signal that in turn creates your fire alarm if you indeed have smoke in the system. Finally, we exhaust the air, sample air either directly out of the detector or back from the detector by means of more pipe into the space. The application of air sampling smoke detection in its most basic form is really not rocket science. A sample hole in the pipe is considered equivalent to a spot smoke detector. And that's right out of the NFPA standard number 72, talking about air sampling smoke detection. I'll make that point again later in the presentation. The way it's applied in the room is actually pretty simple too. If you take a room and you consider where you would position spot smoke detectors, and there are already well-established practices for coming up with that design, then basically all we're going to do is connect the dots and call them sample holes. We connect the dots with the sampling pipe itself. And remember, those holes can be either drilled directly in the pipe, or they can be, as we said before, the drops attached to the pipe. Either one. And then finally, we install the VESDA detector on the end of that. And there's your layout, there's your application. That's not all we do. I'm going to show you a couple other things we do as well. But that is the beginnings of a code-compliant application. It doesn't have to be laid out in one particular way. We can do other things. Here I'm showing the same sample hole locations, but we've got a different arrangement of pipe getting to those same locations. What we're trying to do is accomplish two primary things. Number one is we don't want the transport time from any sample hole to exceed 120 seconds to get it back to that detector. What that means is any smoke going into the most remote sample hole has to get back to the detector within 120 seconds. That's right out of the NFPA 72 codes. Now typically when you get into something like vaults, we apply a more stringent code than that. It's not a code, it's actually just an engineering air in just the holes that are closest to the detector and pulling no air in at the holes that are far away from the detector. If we're doing that, that's not good fire protection. We're not getting any detection out of the end of the pipe if we don't balance the flow in the holes of the detector. How do we do that? We do it with our Spire airflow calculation software, which enables us to basically input information about how the pipe's laid out, where the sample holes are located. It generates flow calculations, we call them. Those flow calculations predict how much air is going into each sample hole. Is it balanced? If it's not, we're going to get error problems and signals that will cause us to go back and change that design to make sure it's going to perform properly. So, with the Spire calculations, we're trying to make sure our transport time is good, and that we're getting equal airflow in each hole. We're complying with NFPA standard 72 requirements by doing those calculations, and it generates a simple report that can be very easily understood by your engineers, people responsible for the performance of that system. Sensitivity, as you probably figured from the acronym, very early smoke detection. Sensitivity is going to be much more than your regular spot smoke detectors, if you want it to be. Okay, it doesn't have to be. We actually configure these detectors sometimes for coal bunkers, sawmills, switchgear in steel mills where fly ash is going all over the place. The detector has a broad range of sensitivity, so it doesn't have to be a true VESDA in that sense of the word. I'll tell you more about that. But first, let's say a word about detectors without trying to get too technical about all this. The smoke detectors you're used to seeing in your house or in your hotel corridors, they have a rating of what we call percent per foot, 1 to 3.5% per foot. That's how much smoke needs to be in the air for those things to go into alarm. Just to give you an idea, at 4% per foot, you could not see the exit sign in the back of this room if you're 100 feet away. At 100 feet away, you cannot see an exit sign if there's 4% per foot smoke in that room. Okay? So, that gives you some idea. That's eye-watering, throat-choking smoke. With the air sampling detection system, we can go between 15 and 10 thousandths of a percent per foot. Believe me, we'll never do that in most of the applications you're ever involved in. Intel, on the other hand, they have semiconductor manufacturing facilities. They like that sensitivity. That is a very sensitive device. You're talking about a clean room application, so you have to have something that's very sensitive to detect smoke in those kinds of environments. You won't use them in vaults. In vaults will probably be something more like 0.02%. That sounds very sensitive, but believe me, it's a good value to use. I'll tell you more about that as well. But look at this, it goes all the way up to 6% per foot. That means it can be less sensitive than a regular detector. You won't use that either, because as I told you, 4% per foot is a lot of smoke. The only reason I show you that is I just want to convey to you that this detector, if properly configured, is not a hair trigger sitting there waiting to go off and give you all kinds of unwanted alarm conditions. The first generation of VESDA detectors didn't have this feature. Basically, the only thing they can do is be very sensitive detectors. And so they didn't have this flexibility we're talking about. And I dare say we probably are still living a reputation, even our acronym. We don't want to drop the VESDA same device basically in all applications. This kind of protection is not. We configure it one way for malts, another way for a semiconductor facility, and yet another way for a sawmill. So it is designed to fit for purpose for these applications.
Excuse me, how did you determine the concentration amount of volts at 102?
That's just a typical. I'm not saying that would be for every case. That's only based on experience. In our experience, we'll see something like probably 0.002 as the background. Every facility has a background level of particulate that is the same size as smoke particles. So in our experience, what we have noticed is that 0.002 would tend to be your background level in a vault. Also in a computer room facility, they tend to run about the same. We might get in there and set it up and find out, for some reason, you've got more particulate in here. No problem. We bump up the threshold of the VESDA detector so that we don't get unwanted alarms. We're only looking for a rise over that background level in order to register a reliable alarm signal. What we're talking about doing with the VESDA system is using 4 different what we call smoke thresholds. And what we do with those is we will typically set up very early warning thresholds in what we call the incipient phase of the fire. And what we're doing with those is we're telling you in a very early warning basis something's going on. Especially that first year. Something unusual is going on. Go have a look. At this point, we would not start rolling fire trucks, evacuating people, and powering things down. Just go have a look. As you move up through the subsequent thresholds of alarm, then you start taking more drastic action. The good news is you already had a chance to do something before you got to that point. Especially before you got to perhaps that 4th threshold where you had to dump a clean gas system or, God forbid, water in your facility. It's good to have a broad span of thresholds so that you get plenty of alert, but you still got that final capability if you need it. We also invoke time delays on each of these thresholds so that when you exceed that threshold, you have to get there and you have to stay there. Typically 10 seconds is what we recommend on that. 10-second delay, smoke goes above that level, we lock it in and say, hey, we've hit alert, we've hit action, or we've hit fire 1 or fire 2. So that's what we're trying to achieve here. Listings and approvals. This is important because the fire marshal is going to come around and bless a lot of the facilities that we're talking about here. Fire marshals, municipal authorities, they want to see that UL listing. Without that UL listing, you can get into some headaches. We are UL listed to standard 268, which is the same standard all other smoke detectors are listed for in commercial applications. We're also listed 268A for duct detectors, factory mutual approved, including class 1 and 2, class 1 division 2 applications. And then the various other approval agencies, Affluent, France, New York City. Yes, if you have some storage facilities in New York City, you're going to need MEA approval. Because of the broad range of sensitivity and the other capabilities of the system, we have found our way into a lot of different applications. I didn't want to read it to you, I just wanted to show you that it is a widely applied product. Customers, as somebody mentioned here earlier, you may recognize a lot of these customers as your own if you're in the data storage business because they also run data centers. And that's probably where VESDAs are most widely known, is people that operate data centers. So we have run a pretty good list of users of the VESDA product. And it's more or less what I call standard for them. And it might be something you want to think about when you're showing what you facility, you got the orange pipe. Why do we need it? Here's the big question. This is really the meat of the whole thing. Why do we need air sampling smoke detection? Here's the reasons that I would imagine you're going to run into in data storage. Rather than read that list to you, let me just take you through each one here briefly. Early warning is primary. Early warning is the key reason that most people will want to use VESDA detection. As the notes indicate here, your damage isn't going to come from heat, from the fire. It's going to come from other things. And one of those is that smoke is corrosive. When it combines with moisture in the air, what you get is usually some kind of acidic compound that's going to start corroding anything metallic. So what we're hoping to do with the use of VESDA detection is take what could be a fire event and make it more or less a maintenance event. You've had a light fixture, a ballast light fixture, and it started smoking and creating a potential problem. Turn the lights off, get it dealt with, and keep going.
Excuse me, can I just ask one question? How closely can you isolate the fact that there is a fire? How closely can you say that there's a fire in, for example, the second floor at the back? Can you get it to be quite specific on where?
Zoning or zoning it down to where the problem is.
And how close can you get the zones?
It depends on how many detectors you want to use. Basically, this detector is a one-zone detector. It'll tell you that somewhere along the sampling pipe, there's smoke. We do have other models that I'll show you in a minute that have multiple pipes that can tell you which pipe sees the smoke. So basically, it doesn't know which hole the pipe went into, but you know which pipe it went into. And then if you provide more and more detectors, my sales guys would love you for that. If you apply more and more detectors, then you will get more better pinpoint accuracy of where the fire's coming from. Question?
Traditionally, how much smoke damage is normally caused before an agent dump to put a fire out? So if you're storing computer backup tapes, is there a possibility that if you don't have sensitive enough detection and you can't get in to put that out, that damage to tapes will occur before an agent dump?
I don't know if there's specific data on that, but yeah, the general statement and the obvious would be that the longer the exposure, the worse damage you're going to get, and the higher the exposure, the worse damage you're going to get. So what we're trying to do is get the earliest possible warning and the lowest possible exposure prior to dealing with the situation. I don't have the ability to quantify that for you.
But in your making a guess, I've never been involved in an agent dump of these kinds of agents. But how bad does the fire have to get normally before they'll dump?
Hinsdale, Illinois, in 1986, there was an AT&T facility that had a fire. And the fire was contained in a very, very small portion of the building. It was extinguished after about, I think, an hour. They had some problems getting all the power shut down. Telephone companies got a lot smarter in 1986. But the point is this, the fire was contained in a very small area on the first floor. Several levels up in the building, they lost equipment due to corrosion. And that was about an hour exposure. So the corrosive environment is definitely there, but it depends on the scenario. The scenarios are so wide and varied that you can get more, what material is overheating. I can tell you this wire insulation, that's probably one of the nastiest forms of smoke you can get as far as corrosivity, versus a circuit board, which won't tend to be quite as corrosive. As far as the specific quantities, I don't know if studies have been done to really try to nail it down. Question?
Is there a limit to how much pipe you can run to one detector?
Is there a limit to how much pipe you can run? Okay, you trying to stay within two limits. Number one, you're trying to keep the transport time down to within, let's say, 60 seconds for most of the environments we'll be talking about. That's a limiting factor. And the second one is we don't want to get out of balance on airflow. We want the airflow, the last hole, to be not way out of whack with the airflow of the first hole. So those are the factors that will tell you how far you can go. I've done designs with our little detector here that have about 120 feet of pipe. I've done designs with our larger detector where we've got 4 pipes going in with a combined total of over 800 feet, and they all met the criteria. One of the other things we get into, if you're into the world of data centers and IT, is that you have a high airflow environment. And in that kind of a situation, smoke detection at an early stage is a real challenge. The reason for that is simply that smoke does not rise. Okay? Smoke follows air currents. It does not rise. If you see smoke from a campfire, it's not rising because smoke rises. It's rising because the airflow above the campfire is vertical. In a high airflow environment like an IT center, the airflow is usually horizontal, and the smoke is doing the same thing. So what we try to do is capture the smoke at the intakes to any air handling equipment that you have, because it's going to get there before it gets totally mixed and churned and diluted in the entire space of the room. So one very effective way to achieve early warning, of course, is to put the sample pipe, as we illustrate here, right over the intake grill where we can catch that smoke at its earliest possible stage. In a computer room, we do some smoke testing, as we do in a lot of our installations. We burn a piece of wire that's 30 inches long. The smoke just takes off and disappears. And the first place we always see it is not at the ceiling, but rather at the return area. We simply mount the pipe above the return air grills. Here's an example of just that. We've got some typical computer room air conditioners. Air is flowing in through the top of those units and out is pumped out onto the floor. So we're picking up the airflow over these units. Somebody asked about zoning a minute ago. How do you know where the problem is? In a high airflow environment, no matter where you detect it, it may or may not have originated from the place just because you see it at the ceiling. What we do is we detect it in these units, and we can tell which unit sees the smoke. But in a higher airflow environment, we don't know where the smoke started or where it came from. That's just the nature of the beast. Okay? You've got to use the good old human nose once we detect it to investigate to see what's going on.
So is this a complementary system in terms of you would still need a smoke detection system as in individual detectors? Because
We
you
say,
don't know where the fire, for example, where the smoke's coming from.
well, what we're saying is the spot detectors, no matter where you put them, aren't going to give you that information either, because the smoke is going to take such a migratory path so rapidly that a spot detector will tell you, yeah, I'm the first one that saw the smoke. But so what? It started 50 feet across the room. So I don't know if I'm making sense. I think that what I'm trying to tell you is there's no real easy way to automatically pinpoint the source of the overheat just from smoke detection. From that point, you need to go out and have a look. Here's another example. Return air grill on the wall, where we've got an entire room behind the wall that's at it's an intake or an air handling room, if you will, a mechanical room. And yet another one with the air conditioning unit right in the room. There's the pipe over the grill, sample holes in it. One of the effective means of early warning is to take samples right out of critical equipment cabinets, server cabinets, for instance. And we've done that on occasion where particularly early warning was desired. And then in conjunction with suppression, we like to emphasize the fact that early warning is a nice adjunct to suppression because it gives you These detectors must be tested annually, or no exception. But the way you test them is unique. In order to test their sampling system, we need access to the detector and to the last sample point of the pipe. All we do is we introduce smoke at the last sample point, and we measure the time it takes for the detector to register that smoke, and that's measuring the health of the whole pipe. We compare that value with the value when the detector was initially put online, and if it's the same, the pipe is healthy. If anything changed about the health of that pipe, under the floor, on the ceiling, if it's blocked or repeated somehow, it's going to show up in that transport time test. Now what that gets you is an advantage in which you don't have to lift these floor tiles up every year and go under there and find regular detectors and test them and probably clean them because an underfloor happens to be kind of a dusty application. Saves time. Saves money. You can get to the detectors on the wall, and you can get to the last sample point much easier than you can climb around and find every detection point. This happens to be a computer room facility, and this fellow is checking the detector. We've got pipes going to the ceiling, and pipes going to the underfloor space from this detector. In the case of vaults, you may also have some security concerns. Okay? You may not want people in the room, or it may just be a big hassle to have people going into a secure room. And the way we can deal with that, and we've done it on occasion in particularly sensitive areas, is we put the VESDA detector outside of the protected space, run the pipe in the space, and we exhaust it back into the room so that we're pulling out an equal pressure space and exhausting back into the same space. Finally, we put a removable sealed-in cap on there, and that becomes our test point. Now, in order to test that system, you need to be able to get here and here, but not here. So if you've got a particularly high security area that you'd rather not have a contractor coming into and accessing, a lot of times they don't deploy the same people for a full year, and you'd rather just, keep them out of there if you can. This is one approach that you can take to do that. We can get into situations where your ceiling structure can pose particular obstacles to smoke detection. Put these little hockey sticks in and branch off on our pipe basically up into the space. And so just in summary, I just want to say we are here with air sampling because of your need for early warning detection. We're here because you won't want to operate a suppression system unless it's really needed. You want to make maintenance of those systems less costly and easier to do, and you want to maintain the security of your site. Those are the reasons why air sampling detection is out there, and why this is a solution to a lot of situations in data storage. Just briefly, I'll take you through our products. This is the Laser Plus detector. This is the one that some people that already have VESDA is called the blue detector, the big blue detector. Okay. It has 4 sample pipes, and it's listed for covering up to 20,000 square feet. Realistically, I can tell you, you seldom get more than 15,000 feet of coverage out of it, even though it's listed for 20,000. And the reason is that transport time. I want to keep that transport time below, 60 seconds in this case. This is the scanner detector, which has the ability to tell you which pipe sees the smoke. The plus detector does not. It's a single zone detector. This one can tell you which pipe sees the smoke. Here's a smaller version for 8,000 square feet of coverage, called the compact single pipe. The one I have with me here today, the Focus, which is available as the 250 for 2,500 square feet of coverage, and its cousin that can cover up to 5,000. So we've got a small to big, scalable range of products. and then the ability to put those devices together on the network so that you can put displays in one location and see how things are going in your facility in one place. Through these sub-racks, there's the displays that give you an indication of what each detector is doing. You can rack them up, as we show here. This is 19-inch rack type assembly. And we can monitor those on a computer front end, either locally or over internet protocol, so that you can have a number of sites stretched out over a broad geographic range, worldwide actually if you want to, because wherever you've got internet access, we have the ability to report back to the computer front end. We have the ability to put AutoCAD floor plans that display, help you drill down to the location in your facility where the problem has been detected. And also, out of this list, I just wanted to tell you, let's see, here we go. Notification by email on your BlackBerries or your Treos, so that you can send those to key people responsible for running the facility, send it to person A